So, hello guys. Kami rin Group 3 reporter last week on about aning nga topic protection and question lang po recap. Unsa gali ang power surge? Hello everyone. Okay, Lloyd, yes Lloyd. Hello, si Lloyd.
Audible na siya. Madunggan. Sige po.
Madunggan.
Madunggan dahil.
Madunggan.
Ang power surge kay kanang pagkalit nga electrical current or kanang kuan. Gana. Ah, voltage kanang very short in duration lang siya ba?
Okay. Correct ka Lloyd. Salamat. Ako na padayon ang topic.
So let's move on to what causes power surge. So ang pinaka-common nga cause of power surge is lightning strikes. So mostly dili na to siya kontrolado no. Since if nagpuyo ka sa rural location or area na where metal in your home can act as an attractor to lightning, so you may wish to consider installing a lightning rod near the premises. Next, bad or faulty wiring is cause of many power surges. So bad wiring will need to be replaced. So you can consult a professional electrician if you think your wiring is faulty. Lastly, high-powered home appliances such as air conditioners and refrigerators require a lot of power to switch on. So when these appliances request this power, they can inadvertently create a spike in your electrical system. So these switching surges aren't as severe as lightning surges, but they can still do damage and wear other circuits over time. So let's talk about surge protection device or SPD. It is an electrical device that prevents power surges from reaching electric and electronic equipment or other device. So SPD works by instantaneously limiting the transient voltage from a power surge to a level that is safe for the equipment. They protect by diverting the large surge current safely to the ground. So ordinary surge protectors simply divert harmful surge current from the hotline to the neutral and ground wires. But this will increase the likelihood of damage to audio, video, and computer data lines because these lines use the power line ground wire circuit for the reference voltage. So more sophisticated surge protection technology is designed so that unwanted voltage are not passed through protected equipment via power, telephone, or other cables. They can prevent excessive energy from reaching sensitive parts of equipment or systems by disconnecting signal lines and diverting surges to earth. Once the surge current has subsided, the advanced SPD automatically restores normal operations and resets to a state ready to receive the next surge. Moving on to types of surge protection device. So first type of SPD is metal oxide varistor or MOV. So it is a semiconductor device usually mainly on AC power applications that has surge ratings ranging from a few hundred to many thousands of amps. So it is used to protect the circuit from high voltage spikes by varying its resistance. Next is gas discharge tubes or GDT. So it is a primary surge protection component with a surge rating of several thousand amps that is compromised of a sealed tube containing a special gas that breaks down at a given voltage rise time. So it is used to protect personal and sensitive equipment from hazardous transient voltage. So when a voltage greater than the GDT's rating is exceeded, The increased voltage ionizes the gas, allowing it to conduct electricity and divert the exist voltage to ground. Zener diode, a secondary surge protection component used for accurate clamping of surge voltages. So it has quicker response time than the GDTs and provides a more accurate clamping voltage than MOVs. So they are used to generate low power stabilized supply rails from a higher voltage and to provide reference voltage for circuits, especially stabilized power supplies. Lastly is the hybrid circuit. So it is a circuit comprising different types of surge protection component, taking advantage of each component's strengths. For example, a hybrid may combine the high surge capability of a GDT with the accurate voltage clamping of a surge diode. So it is an insulating materials, usually a ceramic board, on which passive components such as resistors and capacitors are generated and integrated through a photolithography process using special inks. So its size is very small. And the price of hybrid circuits is very competitive. But at first, they were so expensive that only large companies like aerospace and military could afford it.
Inrush current protection. So what is inrush current? Well, inrush current or input surge current refers to the peak instantaneous current measured in amperes drawn by an electrical appliance or piece of equipment such as power supplies, AC motors, lamps, and lighting ballasts when it is first turned on. So the currents can reach up to 100 times their average steady-state value. On a normal 60 Hz cycle, this momentary surge of current usually lasts from less than 1.5 cycle to a few cycles depending upon the piece of equipment being powered. For example, AC electric motors can draw several times their normal full load current when first energized. Incandescent lamps have high inrush currents until their filaments warm up and their resistance increases. And transformers can have an inrush current up to 50 times larger than normal rated current flow when first energized. So, therefore, usually an inrush current is not dangerous, but can be a nuisance because the high surge of current can blow fuses and trip circuit breakers, thereby shutting down the circuit. Inrush current limiter. Inrush current limiter protects circuits that encounter high inrush loads up to 30 times the rated current for 1/2 cycle at 60 Hz, and it also eliminates nuisance tripping. The inrush current limiter's nature allows resistance to reduce when more current is supplied, allowing the current to flow freely. NTC thermistor. So what is thermistor, by the way? Thermistor is a thermally sensitive resistor with a resistance that changes significantly and predictably as a result of temperature changes. The most commonly used technique to limit inrush current are the negative temperature coefficient or NTC thermistors for power supplies and motors. So when equipment is first turned on, the NTC thermistor is cool and its resistance is high, which limits current flow. Resistance decreases rapidly as the thermistor self-heats, which then allows near full current to flow. So the amount of time it takes for a device to cool down depends on the device, its mounting method, and the temperature of the air. A typical cool down period lasts around 1 minute. So allow me to discuss again or to explain again about the thermistor. So when the system is powered on, it energizes the NTC thermistor, causing the temperature to rise. and thus lowering resistance. As resistance drops to a low value, the current passes through without adversely affecting normal operation or power efficiency. So to limit inrush current, an NTC thermistor is placed between the power supply and system. Upon power on, the NTC thermistor provides high resistance to limit inrush current. As the inrush current drops, the NTC thermistor self-heats and its resistance drops to a low enough value to pass current through. Thank you.
Good day, everyone. I will continue to discuss the subtopic under occupant protection and equipment protection, which is lightning protection and equipment for hazardous location. Let me introduce first myself. I am Joey Bonglay, 20 years of age, residing at Tibagot, Tagindingan, Misamis Oriental. We will discuss first about lightning protection. Did you know more than 100 lightning flashes occur every second in the atmosphere, which, which equates to about 8.6 million per day and over 3 billion annually. About 20% of these flashes actually strike the ground. Lightning discharges have been measured from 2,000 amperes to more than 200,000 amperes, with rise times to peak current of less than 10 microseconds or 10 millionths of a second. So imagine 2,000 amperes to more than 200,000 amperes ang kilat nga makaigo sa isa ka tawo, di ba? To matik na daan, abo. In the United States, about 200 people are killed 250 people are killed annually by direct lightning strikes, and another 500 will die in lightning causes fires. Additionally, at least at least 1,500 persons are injured by lightning each year. Many of the deaths and injuries would not have occurred if proper lightning protection equipment was installed. Yet, the Lightning Protection Institute reports that 95% of today's homes are not protected against lightning surges. The idea of protecting buildings and other structures from the effects of direct lightning strikes by the use of protective conductors was first suggested by Benjamin Franklin. So, vertical lightning rod. So, muna siya na yung kuan, guys. Muna siya ang nakong kibali sa lightning rod. Okay? So, usually makita ni siya sa mga dagko ng mga building para if ever na ay kanang direct lightning nga mo strike sa isa building is kani siya ang mudawat kibali. So, para ma-minimize ang mga damage sa mga electrical system. So, let me continue. Sometimes called air terminals, are placed at the top of the protected structure. These lightning rods are equally spaced a maximum of 20 feet apart along the high points on the structure. Rods are also placed within 2 feet of the building ends and on the top of cupolas, chimneys, antenna masts, and towers. A network of conductive copper or aluminum tape, thick flat cable binds the rods to grounding electrodes that are driven into the earth. Metal roof vents in proximity of the lightning rods are also bonded to the conductive tape. So mo siyang illustration kibali kung giun sa pagtaod ang lightning rod. So ang lightning rod is nasa sa ibabaw kay bale ang lightning kay mo pam siya. So from above man siya, di ba? Oh, from above. Dahil siya may mudawat sa dahil sa kilat para dili kay siya direct sa kumbita sa atong mga equipment. For example, kung makakuha siya sa atong service line o padulong sa tua, siya mo ibali mo dawat og una din para sa ma-minimize bitaw ang ang kuan impact ibali sa atong mga equipments or electrical equipments. Then na siya nakalubong na ground rod and electrical lightning rod, then na siya wire padong sa ubos, then na siya ground rod nga gilubong. A lightning strikes does not have to direct contact with the building to cause damage. The building's electrical system. A lightning strike on nearby power lines can induce high voltage that damage the building's wiring system and electronic equipment within the building. Although proper grounding of the building's electrical system can limit damage to the building's wiring, unprotected electronic equipment is usually damaged. A surge protection device can minimize the damaging effects of a lightning strike. So, kibali mo itong explain ganina, once ang atong service line ang maigo, so dili siya directly nga madaot gid ang atong mga electrical equipment kay naman tay lightning protection equipment nga gigamit. So the second subtopic is equipment for hazardous location. In hazardous locations such as gasoline station, paint spray booth, or factory, explosion-proof or resistant equipment and wiring must be used. A hazardous location is a location in which fire or explosions hazard may exist because of the presence of flammable gases or vapors, flammable liquids, combustible dust, or easily ignited fibers under normal operation or abnormal operating conditions. Types of hazardous locations are grouped by class. So muna siya ang hazardous location types. Class 1 is naka-class 1, class 2, and class 3. Under sa class 1, according to National Electrical Code or NEC, there are 3 types of hazardous locations. The first type of hazard is 1, which is created by the presence of flammable gases or vapors in the air, such as natural gas or gasoline vapor. So, a class 1 hazardous location is one in which flammable gases or vapors may be present in the air in sufficient quantities to be explosive or ignitable. So, ang example kaning mga sa class 1 is kanang tong gasoline station. So, since nadira ang gasoline vapor kay gasoline station man. So, some typical class 1 locations are petroleum refineries, and gasoline storage and dispensing areas, dry cleaning plants where vapors from cleaning liquids can present, spray finishes areas, aircraft hangars and fuel services areas, utility gas plants and operating involving storage and handling of liquefied petroleum gas or natural gas. So, under sa class 1 is more on na siya kanang mga gas or vapor nga which is kung makakuha lang gani siya o siga or spark is dali ra siya mo mo kuan kibali ang it's either ang kalayo or mubuto ana. Class 2, the second type of hazard listed by the National Electrical Code is those areas made hazardous by presence of combustible dust. These are referred to in the code as class 2 locations. Finally, pulverized material suspended in the atmosphere can cause as powerful an explosion as one occurring at a petroleum refinery. So, ang kanina pong sakuan sa class 2 is kuan siya, kanamo tong mga mga dust or abog-abog nga mura siya kanang dali ra bito siya makuan masunog or tigingan something like that. So some typical class 2 locations are grain elevators, flour and feed mills, plants that manufactured, use or stored magnesium or aluminum powders, producers of plastics, medicines, and fireworks, producers of starch and candies, spice grinding plants, sugar plants, cocoa plants, and full preparation plants, and other carbon handling or processing areas. So, sa class 3, according to National Electrical Code, are areas where there are easily ignitable fibers or flying presence due to types of materials being handled, stored, or processed. The fibers and flyings are not likely to be suspended in the air, but can collect around machinery or lighting fixtures and where heat, a spark, or hot metal can ignite them. So, example, some typical class 3 locations are textile mills, cotton gins, then cotton seed mills, flax processing plants, and plants that shape, pulverize, or cut wood and create sawdust or flames. Explosion proof receptacles, switches, enclosure, fixtures, equipment are specially designed to withstand an explosion that may occur within it, and of preventing the ignition of a specified gas or vapor surrounding the enclosure. Conduit that is used in an explosion-proof location must be sealed so that gas may not move from one enclosure to another. So ang kuan gid ani is ang mga example chip-tapo switches or other mga materials nga equipment nga ginagamit is nakakuan gid siya, naka-sealed gid siya og tarong nga para dili siya masudlan or for example sa gasoline station. So dili gid siya ordinary lang nga switches ang imong gamiton, di ba? So kay kung for example ordinary lang like sa kanang sa atong mga sa atong balay like nga natong mga switches nato, di ba? So usually mag-create ang spark kag naay ga-create nga spark once atong siyang i-on, di ba? Since magtagbo man ang kuan duha ka wire, so usahay na gina siya spark. So ang spark is bawal bigid na siya sa kuan gyud sa kanang mga expose og mga kuan sa mga gases kay you know mambuto gyud. So mo siyang example of explosive proof. So as you can see, ang mga kuan nila either ang light nila is nakaseal gid siya tarong, di ba? Example ani siya kani like grabe gid kay siya sa ka-sealed sa usually ginagamit nila is kuan gid siya naka-metal siya. Metal siya then natarong ni siya sealed kay if ever musiga siya dili siya makakuan dili siya mo maka-create og something spark ba or nga magka-cause og kalayo. So in contrast, explosion-resistant equipment is designed to prevent ignition of an explosive or flammable material. And that's all. And thank you for listening.
We're done, sir.
Ako man ang group 3.
Yes, sir. Thank you, sir.
Okay. Please, kompleto na. Kita ninyo display, guys.
Yes, sir.
Yes,
Parang sama klase, sir.
Okay. So, karon na adlaw is the start of a new topic titled Electrical Design Principles. So, dere ta makatuon kung unsay mga standards, mga considerations and factors sa atong pag-design sa isa ka electrical design or rather electrical system sa atong mga buildings. So there are 4 objectives para ani nga new chapter. So first, name, describe, and distinguish between types of building system voltage. So natay 120 volt or 240 volt nga system or 240 volt or 480 volts nga system. And buildings in which they are used. So there are 3 types of building establishments. So there is residential, commercial, and industrial nga setup. So determine na to kung asa unsay voltage level na pwede gamiton sa kada establishment. Later mabala na to na. Next, identify, describe, and distinguish between types of building distribution equipment. Next, compute the minimum required size of branch circuit components. And lastly, interpret design information of building electrical system components. So, I guess pwede na nako ihatag kang group 5 ang klase karon. Group 5.
Hello? Hello, sir?
Tama na.
Madunggan na, sir.
Yes.
Sige.
Sir, di mas scared silang presentations. Disclaimer, ano.
Ay, disclaimer.
Sir, sana hindi kami mababagsak, sir. Thank you very much.
Grabe sad.
Makita ang presentation, guys.
Yeah.
Yes.
Okay. Sige.
Unique kayo.
Go.
Okay.
Rated R.
Sige, let's start.
Wait.
So, should I open it? Hello guys, my name is Jovan Basadas and I will be the one who's going to be an MC for our group. So we are the group 5. So here are the reporters for today. As you can see na si Lord Vincent Ortiz, Paul Vance Nisperos, yours truly, Ren Postanes Villanueva, Muhammad Ali Chari, oh my God, Muhammad Ali, Dams Lester Tabuelog, Shane Khan Valdeza. So our first reporter will be Lord Vincent Ortiz.
Hello, hello. Dunggan na ako, guys.
Hanggang ron.
Tunggan radal.
So, good evening, sir. Good evening, everyone. So, our topic for today is all about electrical codes, licenses, and permit. So, electricity is everywhere. It's the greatest achievement of humankind, and it affects every aspect of our lives as a, as the world becomes interconnected more, and more areas of our lives will be soon be powered by electricity. Codes and standards help us use electricity in an efficient manner. Let's talk about electrical code. So what is electrical code? Electrical code is a design of an electrical system that applying the standard written into the building code. It also an electrical that specifies the minimum provisions necessary. It also applies to both manufacture and installations of an electrical equipment. Next. So, next, National Electrical Code. National Electrical Code sets the minimum standard for safe electrical installation, and it's updated every 3 years to ensure that the electrical system will be safe behind our walls. So, what is the National Code? A National Electrical Code is a set. Wala na, wala. Giwo kita sa percentage. Oh. The National Electrical Code is a set of specification and standard in a form of a model code that can be adapted into a local law by the local governmental entity. And the National Electrical Code was established in 1897 through the combined effort of insurance, electrical, architectural, and other interested groups. And in 1911, the National Fire Protection Association or NFPA became their sponsor, so continues to act in this capacity. And the National Electrical Code is updated to every 3 years to ensure the electrical system are safe. Pero guys, bisan pag ma-update ang National Electrical Code kay there's other ang kuan Japon ang city ordinance kay mag kuan pa Japon sila kanang required pa Japon sila use gamiton ang kuan ang previous edition compare sa kuan na bitaw release na pod ang new ma-release na pod ang new edition. So next. So muna siyang National Electrical Code. So next is the Canadian Electrical Code. It provides safety standards for installing and maintaining the electrical equipment so as to minimize the electrical shock and fire hazard. It also reminded that the electrical installations should have sufficient capacity not only to meet today's demand but to allow for future growth. So, Canadian Standard Association or CSA, it is an association that publishes and administers the Canadian Electrical Code. So, sila ang gahawid sa CSA nga code. Next is the Canadian Electrical Code Committee. It represents regulatory authorities, manufacturer, Installers, Consumers Group, and the Canadian Electrical Association or the Utility Industry Advocate. And it also established safety requirements for electrical work and installations for the electrical equipment operating or intended to operate and all voltages and electrical installations for buildings, structures, and premises across Canada. And CEC is similar to National Electrical Code but not identical because CEC is revised every 4 years compared to National Electrical Code is updated every 3 years only. So in CEC, when a new edition is published, Canada's provinces and territories act to adapt it into legislation. As the code is revised and a new edition is enacted into local law, previously acceptable regulations may be become updated. So it means na if ma-release na siya if ma-release ang new editions na siya prefer required 4 years kay ang katudang mga na siya nga pwede gamiton unlike sa National Electrical Code kay still yung nga pwede pa siya magamit bitaw bisan pag ma-release na siya new edition. There's a law Japon nga nag-allow bitaw nga ang electrical is called grandfather clause nga which allows bitaw nga if nagkuan kag business or property nya naabtan ka sa time nga nag-release na pog new edition. So this law kay pwede siya maka allow nga mag-operate ka sa imong kuan gatukod kag building or property. Next. Next is the manufacturing standard. Today, all electrical equipment, appliances, and devices should meet specific safety standard based on the regular product testing. Quality control is important for manufacturing and it demonstrates that your organization is customer focused and committed to delivering consistent. So, Underwriters Laboratory, it's not for profit product safety testing and certification organization, but it is the third party certification organization has been evaluating product in the interest of the public safety since 1894. UL is a leading developer for the safety standard because it designed to be compatible with the national recognized installations, buildings, and safety codes in United States and the other North American countries. The National Electrical Manufacturing Association, or NEMA, is a leading trade association in the United States representing the interest of the electrical manufacturer. So, this association has been developing standard for the electrical manufacturing industry since 1926, and today it is one of the leading standards development organization in the world because it contributes help to ensure the public safety. So next, next is licensing. A license is a legally binding document or contract that allows someone to carry out some action or use a service. In other words, a license is permitting someone to do or utilize something. So, most municipalities have ordinance or local laws that require that any person who wishes to engage in a business or installing electrical system must be licensed. This means that a person must have a minimum number of years of experience working with a license. Licensed electricians and must pass a written test that deals with the electrical code being used and usually assured that the electrician knows everything, especially the code requirement and the installations procedure. So it means na need jud dagwan guys kanang license nga electrician bitaw nga mag manage siya if mag magkuhan tag electrical wirings bitaw for the safety purposes na po siya. So next is permit. Permit is different from licensing. The main difference between permit and licenses is that permits are the legal and official document released or issued by the authority as approval to proceed with some activity or business entity. It simply represents the permission. So most municipalities that require a permit be issued before any electrical installation may be made on a project. A complete electrical construction drawing also be required for review and approval by a plans examiner before installation begin. In general, most municipalities that require electrical permit is also required licensed electricians. So before daw matagaag permit, dapat need po dog license nga electrician para sa mga electrical wirings nga itukod sa isa ka building. So municipalities that require a permit will also have an electrical inspector who check the project during regularly scheduled visits. So it means na they will inspect the installation after the rough wiring but before it's concealed behind constructions materials. So before ang permit mahatag na po mag kuan mga inspector na mag-check sa mga kuan wirings na imong naitaod sa isa ka building. So before they ko maghatag og quiz guys, short quiz if ay before ang next reporter na maghatag di ko og short quiz if naminaw ba ang tanan. So number 1, what organization became the sponsor of the National Electrical Code to continue act in this capacity? Anyone? So Prince, Edward,
Good evening, guys. Pistol. So, madunggan ra.
Madunggan Ragaw.
So, kuan, National Fire Protection Association or NFPA.
Thank you. Thank you, Prince. So, ang National Fire Protection Association kasi sila ang sponsor sa National Electrical Code. So, next is what clause that allows outdated electrical installation? Unsa nga clause nga nag-allow daw anyone? Ito nag-raise og
Again daw.
What clause that allows outdated electrical installation? Unsa daw nga clause na bisan pag na-release na bitaw ang kuan ang new edition kay makagamit pa gyapon ka sa previous edition nga code. So Kim,
Ang grandfather clause.
grandfather clause. Thank you Kim. Thank you Jason. Correct gyapon ka. So, alright dito guys. Thank you guys for listening. Nakalearn mo.
Okay, thank you so much, Lord Vincent Ortiz. So our second reporter will be Paul Vance Nisperos.
Good evening, everyone. Oh. Next na joke. Wala ko makita do. Philippine Electrical Code. What's the purpose of Philippine Electrical Code? The purpose of the Philippine Electrical Code is the practical safeguarding of the person and property from hazard arising from the use of electricity. This code contains provisions that are considered minimum requirements necessary for safety. Next. Philippine Electrical Code has PIC-1, the electrical installation inside the buildings, PIC-2, electrical installation outside buildings, and PIC consists of rules which are intended to make use of electricity safe for a person and property. These two rules is mandatory rules and advisory rules. The mandatory rules is characterized using the word shall, and the advisory rules is characterized using the word should, or are stated as recommendation of that which is advised but not required. Next, please. The objective of PIC. We have two: safe use of electricity and adequacy. The safe use of electricity is to establish basic materials, quality and electrical work standards for the safe use of electricity for light, heat, power, communication, signaling, and for other purposes. Adequacy is strict compliance with the provisions of the code will ensure safety in electrical installation and construction, but not necessarily efficient, convenient, or adequate for good service or future expansion of electrical use. Next. The use of PIC is mandated by the RA 7920, formerly RA 184, also known as the New Electrical Engineering Law. Likewise, referral codes are also used, which are mandated by their corresponding laws like PD 1096, National Building Code, PD 1185, Fire Code of the Philippines, and Structural Code. Next. The RA 7920 is an act providing of the more responsive and comprehensive regulation of the practice, licensing, and registration of electrical engineers and electricians. Next. Government authorities who implement PEC, Office of the Building Officials, Office of the City Electricians, Office of the Municipal Electricians, and Regional Office of the DOLE. Next. Permits and inspection of certificates. A permit is required before undertaking any electrical installations. And inspection is also required, after which certificates of final electrical inspection is issued by the authority. Next. Requirements for electrical permit. An application form shall be accomplished, signed, and submitted by a duly registered professional electrical engineers. However, if the installation does not exceed 20 lighting or receptacles outlets or 4,000 volt amperes to 30 volts, and the application may be prepared, signed, and submitted by the duly registered electrical engineers or master electricians. Next. The application shall include additionally the name and signature and seal of the electrical practitioner who will take charge of the installation, as well as the signature of the owner or his authorized representative. Next. 5 sets of plans and specifications bearing the signature and seal of the responsible professional electrical engineers shall be submitted together with the application. The 5 sets of sketches and bill of materials may be prepared, signed, and submitted by the responsible registered electrical engineer or master electrical engineer. Thank you. That's all. question. I don't have a question po kay ano lang to siya sa Connie Ortiz. Sumpay.
Okay, thank you so much, Paul, Vincent, Nisperos, for your report. Since they're connected, Paul decided not to ask questions. So this time, it will be my report. Anyways, okay. Hello, madunggan ko ah.
Yes, no.
Okay, thank you. Okay, so let's go now to YouTube. So hey guys, my name is Joe Bambasadas, and again, I will be the one who's going to report your baby is going to have a vlog about electrical construction drawings. So let's start. Electrical construction drawings. So let us first talk about the lesson objectives. First, understand what is an electrical layout drawing. Second, know the specifications, details, and drawings to be used or included. Third, be familiar with the legends and symbols for the electrical layout drawing. Electrical construction drawing. So it shows the layout and design of an electrical installation. A complete set of construction drawings and specifications of the building electrical system is needed to convey design information to the contractor. Electrical drawings, sometimes referred to as wiring diagrams, are a type of technical drawing that provide visual representation describing electrical systems or circuits. They are used to explain the design to the electricians or other workers who will use them to help install or repair electrical systems. So the following construction drawings and details are generally required. First, complete plans and specifications of all electrical work. It helps to ensure that your system runs safely, efficiently, and smoothly. An electrical plan saves time by avoiding delays and problems. Two, labeling criteria of all electrical equipment. If it is properly labeled, a cable managing system can help in solving and detecting exactly where any problems occur. Three, lighting, lighting floor plans. I'm so sorry about that. Including electrical circuits, indicating conduit and wiring sizes. It deals with the actual number of lighting fixtures that a particular room will need. It is really important to indicate conduit and wiring sizes to ensure the reliability, consistency, and safety of the system. Fourth, power floor plans, including electrical circuits, indicating conduit and wiring sizes, equipment, and disconnect switches. It is a thorough planning tool because it gives an in-depth view of your building's electrical and wiring system. So let's go. So fifth, exit signs, means of egress, lighting, location, and power supply. It contains details regarding the placement, visibility, and acceptable forms of illumination for exit sign. 6. Panel board schedule. Panel board schedules are critical for designing various projects and determining the amount of power required for installing and operating them. 7. Lighting fixture schedule. A light fixture schedule can be displayed on the drawing. The schedule lists all the light fixtures used in the project. 8. Symbol schedule and diagrams. The advantage of having this is that it will only display the symbols that are actually in use. Using interactive schedule, this makes a more compact, relevant, and readable table. Let's talk about the specifications and drawings that should be included in the requirements for First, raceway and conduit with fittings. Raceway and conduit with fittings are used to conceal exposed wires for giving the system an aesthetic appeal. Two, wire and cable. They are both electrical conductors, but the difference is that between the two, difference between the two is that wire is a single electrical conductor, whereas cable is a group of wires swathed with sheeting. Third, electrical boxes, fittings, and insulation. Electrical codes generally require that all electrical devices and the wiring connections to those devices must be enclosed in an approved electrical box. Fourth, electrical connections. Electrical connections are any structures that allow electricity to flow in it. Five, electrical wiring devices. These are the finishing touch and a chance to test all branch circuits for proper operation. 6. Circuit and motor disconnects. All disconnect switches will be strategically placed where they can be easily accessed maintenance personnel without the use of ladder or traversing other equipment. 7. Hangers and supporting devices. Design equipment supports capable of supporting combined operating weight of supported equipment and connected systems and components. 8. Electrical identification. It labels for all electrical equipments including but not limited to switch gear, switchboards, panels, transfer switches, and disconnect. 9. Service entrance and details. It consists of the electric meter and the service panel. It is where power enters a residence. 10. Overcurrent protection. It is the method of implementing hardware and other electrical components to limit or disable current flow. 11. Switchboards. It is a device that distributes electricity from one or more sources of supply to several smaller load circuits. 12. Grounding. It is the process of directing excess electricity to the ground via wire. 13. Transformers. Transformer is a passive component that transfers electrical energy from one electrical circuit to another circuit or to multiple circuits. 14. Panel boards. It is a component of an electrical distribution system which divides an electrical power feed into branch circuits while providing a protective circuit breaker or fuse for each circuit in a common enclosure. 15. Motor control centers is an assembly to control some or all electrical motors in a central location. 16. Lighting fixtures are electrical devices containing an electrical lamp that provides illumination. So symbols are used on construction drawings to represent lighting and power distribution components and equipment. Actually, guys, so karon, I don't know if you can appreciate this, but I think na ay mga classmate na ako na-expose na sa construction and all, like construction drawings, models sa construction, and then electrical engineer na sila, ang electrical engineers na sila design na paper, like murag A3 siya na paper and isay nila, and then bali dito makita ninyo ning mga specifications na akong gipangyayaw karon. Although murag not all people residential homes na akong napansin na ginasunod nila ni, but you can see this kaning 16 specifications that to sa plano. Anyways, here are the abbreviations and acronyms to be used in electrical layout drawings. Abbreviations and acronyms are shortened forms of words or phrases. They assist in making manuscripts easy to read and understand. No specific symbol is set universally accepted by the industry. So these symbols provided are typically modified by the engineering consulting firm and used on their drawings. So bali mo siyang shortcut so that it will be accessible for different engineers. For different engineers, and then bali ma-identify dahil nila unsa ni siya, unsa ni kilowatt hour. As you can see, gamit ba yata 6 kilowatt hour kWh. So bali is a shortcut para di na ta magsulat like the whole phrase, the whole word. So here, electrical symbols are required to do the electrical drawing and without the help of abbreviations. So kung wala ni siya, we won't be able to do the electrical drawing. Electrical circuits are represented by electrical drawings. Symbols and number combinations are used to represent electrical circuits. So bali murag naano man ako ni sa AutoCAD, although murag wala mi nakatouch sa electrical plan, napami dito sa architectural katong door, kitchen, something like that. But yes, kani sila kay these are important because we can't make layout, electrical layout. The legend of symbols is an important part of the construction drawings. It should always be reviewed to ascertain the meaning of an electrical symbol on a specific drawing. So, basin magkabulingit ang drawing, ang symbol, it should be reviewed good because what if matala-tala gid ang pabutang dato sa balay, magubang balay, butang balay. Symbols are arranged on the drawings in the form of a one-line diagram. One line represents the conductors extending between two symbols, regardless of the number of conductors. So that's it. Anyways, so I don't know if I will use AutoCAD right now. Maybe there are a lot of you who's kind of ano na sa AutoCAD, but I will just use AutoCAD. I hope na remember ako. Basically, this is like on the spot presentation. I can guess. Anyways, so I guess we have this semester. Last year, second semester. So this is AutoCAD. I will just the symbols. I will not place any electrical layout because di pa man gid ko knowledgeable sa making electrical layouts plans. I will just show you guys ang asa ta makakita or unsay we call this unsa atong tuplokon para mo ato dito sa symbols, electrical symbols sa AutoCAD. So we'll just enter control plus 2. So basically control plus 2. As you can see, why is it glitching? So as you can see, nag-glitch siya. I don't know why. So here are the blocks sa electrical power. Why are you glitching? So nag-create na kong tool palette. Itong daan pa lang. So Control A, select all, delete siya, select all, kaya glitch siya. Hindi na kaya ni laptop. So, create a tool palette and then maka-create tayo kaani. As you can see on the right screen. Unta, di siya muna start. Laban lang kita. Muna siya. And then, there is electronics. Battery, capacitor, circuit breaker. So, these are the electrical symbols. So, you need to create two palette. Bali ma-export sheet to. And it will be easier to add it sa imong electrical. So that's it, guys. Or to akong mahatag because I'm not that knowledgeable. So mo ni siya ang diode. And you can like place a line here. And I think Sir will be the one who will teach us. So that's it. Mo to siya guys sa pagkuha sa symbol sa AutoCAD. Control plus 2 and then makita nimo to nga screen. This screen. Imo dayon i-select all and imo dayon i-create tool para paspas lang pag-insert sa different symbols. So that's it for my part. I hope you guys learned something. Let me another window. So that's it for my part. Now let's go to Rents. Since she has an internet connection problem, she decided to do a record. I will just ask questions after the presentation run. I almost forgot. I will just ask questions, like 5 questions lang after this presentation. So yeah, thank you.
Good evening, everyone. I am Ran Pustanes Villanueva, and I'll be discussing about the building system. Good evening, everyone. I am Ran Pustanes Villanueva, and I'll be discussing about the building system voltages. In building system voltages, there is supply voltages. What is supply voltages? Supply voltages user where the power is delivered by the utility company and expressed as a nominal voltage because it varies slightly. So nominal voltage is a value assigned to a circuit or system of a given voltage class for the purpose of convenient designation. That is why supply voltage expressed as a nominal voltage. Tungod kay ang supply voltage slightly na magkalain-lain na siya. During normal conditions, supply voltages can vary from about 90 to 105% of nominal voltage. Variations from nominal voltages are caused by a number of reasons, including load variation and changes in conditions at the utility power system. Additionally, transient voltages. Transient voltages is a temporary unwanted voltage in an electrical circuit that range from a few volts to several thousand volts. So, transient voltages caused by the sudden release of stored energy due to incidents such as lightning strikes, unfiltered electrical equipment, contact bounce, arcing, capacitor bank or generators being switched on and off. Next is system voltages. What is system voltages? System voltages is the principal voltages available in a building. Medium and high voltage system carry voltages above 600 volts. May be used in special cases such as the 24 over 416 volts three-phase system found in industrial and commercial installation, such as for large signage, sports lighting in stadiums, and services for large manufacturing plants and skyscrapers. So mostly, gakita nato ang three-phase system sa industrial and commercial installation because of the distance and the consume og dako na power, which is three-phase system is an economical way of bulk power transmission over long distances and for distribution. Why they use three-phase system? Because it provides greater power density than one-phase circuit at the same amperage, keeping wiring size and cost lower. In addition, three-phase power makes it easier to balance loads, minimizing harmonic currents and the need for large neutral wires. System voltages. There are drawbacks to voltages higher than 600 volts because significant and costly special precautions such as heavy insulation and conductor shielding are needed. However, as a result, low voltage systems that carry voltages less than 600 volts are typically used in buildings. As I mentioned earlier, system voltage is expressed as a nominal voltage because it varies slightly. Design of a building's electrical system begins with establishing the desired building system voltage. So, higher voltage means that a circuit can carry more current. A 200 volts circuit can carry 1.73 times the current of a 120 volt circuit. To get the 1.73, divide 208 volts to 120 volts equals 1.73. A 240 volt circuit can carry twice the current of a 120 volt circuit. A 277 volt circuit can carry 2.31 times the current of a 120-volt circuit, and so on. Higher voltage means smaller conductor sizes. The savings for larger conductors of moderate length can be quite significant. Higher voltage is more dangerous. Also, the higher current. Both current and voltage are dangerous. For example, when someone is shocked, it's the amount of current that causes the damage. Even small current can kill. On the other hand, the high voltage dangerous because it derives current. There are numerous system voltage levels and combination used in building throughout the world. Availability of a particular system voltage is dependent on utility lines and equipment at or near the building site. In the United States and Canada, several system voltage configurations are in use. However, a particular system voltage may not be available at a specific building site.
So thank you so much, Ren, for that wonderful presentation. So right now I will ask 5 questions to you all. Let me just present my window. Only 5 questions, and then Ren will ask you after. So, so who can give me the abbreviation of National Electrical Manufacturers Association? Yes, Christian Flynn. Okay, thank you so much. Next, katong uban na naka-answer na palihog dili na mag-answer sa next question. Give chance to others. Thank you. Okay, so what's the abbreviation for power? Yes, Shane. Shane. Okay, since Shane isn't around, what about you, Kirby?
It's PWR.
Thank you so much. Third, what's the abbreviation for volt amperes reactive? Yes, Maribel. Yes, thank you so much. Fourth, what about ground fault interrupt what interrupter? Yes, Janiel. How do you pronounce your name,
GFI.
baby? Rose
Janil.
Janiel. Yes.
GFI.
Yes. Thank you. Last question will be what about occupational safety and health administration? Yes, Jeffrey. Yes. Thank you so much for those who participated. I will list your names. So Ren will be the one. She will be the one who's going to ask next. Maybe Ren.
Good, good evening, everyone. Please press the button, raise hand, if you want to answer. First question is, what are the causes of variations from nominal voltages? Again, what are the causes of variations from nominal voltages? Yes, Eliza?
Ah, wait lang. Koan, ano sa balik sa ay the cause of variations,
What
no?
are,
Koan,
yes,
load
what are the
variation.
causes?
Load variation, changes in conditions at the utility power system, ug kuan transit voltages.
Yes, you're correct. Thank you. Next question. What base system usually found in industrial and commercial installation? Again, what base system usually found in industrial and commercial installation? Yes, Medallia.
Kuan, three-phase system.
Medallia.
Kuan, three-phase system.
You're correct, Medallia. Thank you. That's all.
Kinsay next reporter?
Ako, sir.
Lester, sir.
Nahuman ng questions.
Dahil
Mana?
Joby.
Oh, I'm so sorry. Okay.
Yes, Joe.
Thank you, Ren, for the questions, and thank you so much for those who participated. Our next reporter will be Muhammad Ali Shah. How do you pronounce this? Muhammad Ali. Muhammad Ali.
So good evening, sir. Good evening, everyone. I am Muhammad Ali T. Sharif, and tonight I'm going to discuss circuit wiring. So next slide, please. Before we dig deeper into system voltages, let us first introduce the types of wiring found in a circuit. So usually, there are two minimum types of conductor required in a circuit to deliver alternating current to the building electrical system. Next slide, please. So what you see in the screen right now, kanang nasa left, are the types of a single conductor wires. On the other hand, or kanang sa right nga image, is an image of the commonly used circuit wiring which involves the hot, neutral, and ground conductor. And sad to say, based on my research, there are only two types of wiring that are commonly used here in the Philippines, only the hot and neutral conductors. So the ground conductor is usually neglected, but little do we know that it is also very important in a in a circuit wiring, and you will know why later. Next, please. So there are three most common used conductor in a wiring circuit. Each role plays an important part in delivering and regulating the electrical system. So, kani siya makita nato diri ang katong three nga akong na-mention ganina, ang hot, neutral, o ground conductor. So, next slide please. So, the first type of circuit wiring we are going to discuss is the ungrounded conductor or hot conductor. The ungrounded conductor is the initial current carrying conductor in an AC system. The ungrounded conductor is frequently known as the hot or live conductor because it feeds current to the circuit. So both pasabot sa ungrounded conductor is siya ang gadala og kuryente or energy sa usa ka AC system. It is also known as hot or live because obviously si grounded circuit ang pinaka-active sa ilaa in terms of transporting current. That is why init og live siya. Ang importance sad sa hot conductor is kung wala siya, syempre wala mo transmit og power sa atong appliances so dili siya mugana. Then when an ungrounded conductor is grounded, a closed circuit in a closed circuit in single phase results. So pag makonekta ang ungrounded conductor sa grounded is mag-result siya into single phase. Or pasabot pa na is kung ungrounded kay mopilit or bisag duol man lang sa closed loop, una na siya ang ginatawag nga single phase. So take note that single phase is usually used in our appliances. All of our appliances at home is single phase. And a little trivia that both single phase 2 wires and single phase 3 wires uses 120 volts. Next slide please. Now let us proceed with our second type of wiring, which is the grounded or neutral conductor. Talking about neutral conductors, it depends to our voltage system, which was or will be discussed further later on. So a grounded conductor or neutral conductor is required to complete a single phase circuit by connecting the ungrounded or hot conductor to the ground. Ang buot pasabot ana ang kuryente nga gihatag ni conductor pagbalik ang nagikan sa appliances sa neutral na siya modiretso. Kibali si neutral ang musalo. So the role of neutral conductor is to regulate the current inside the electrical system to avoid overflow. Kay kung walay neutral conductor, ang tendency ana kay mabuto ang atong appliances. Kay there is kibali walay balikan ng current nga na store sa appliances. So kung walay neutral, mabuild ang current inside the appliances. That's why mabuto siya. Next slide please. Jump to the last type of wiring, the grounding or ground conductor. A third conductor known as the grounding conductor provides supplementary but important grounding protection. The grounding conductor is not normally a current carrying conductor, but is energized only temporarily. So to put this in perspective, we will give an example. So for example, inyong washing machine is nagka-leakage current o wala na nakakonect ang grounding sa ground. Ang mugawas ana kay ang leakage current na mo'y madala padulong sa atong lawas. So maong if ever mag-washing ta and we try to turn on the machine, will feel ground in our body. Kay the purpose of ground conductor is to give grounding protection so that will not feel ground every time we'll use our appliances. So pasabot jud sa murag grounding conductor is nagprotect lang siya sa atua para dili ta ma-feel og ground sa atong lawas. So mauna na siya and wala na ko'y questions inyo. Thank you.
Since Mads decided not to ask questions, we will now go to Dems Duster, the Buelok. Dems?
Hello, good evening, everyone. So, so I will be discussing about common building system voltages. Next slide, please. So first is 120 volt alternating current single phase two wire system. So that 120 volt alternating current 1 to 2 watt system is the most basic system voltage used. It was used in the first electrical service to buildings. However, nearly all have since been upgraded. Today, this system is used to serve outbuildings and farms buildings because its use is limited to buildings with loads up to 6,000 voltage, 50 amps. Next slide. Only two conductors were used to transmit electrical energy beyond the panel board to the buildings. 120 volts branch circuits before 1945. These layouts corresponds to the two slatted convenience outlets present in older buildings. Today, three conductors are employed, one ungrounded or hot, one neutral, and one grounding conductor. Next, please. Next is the 208 120 volt alternating current three-phase four-wire system. The 208 120 volt alternating current 3 to 4 watts is an older electrical service found in small commercial buildings, office buildings and schools, and high-rise buildings. It is not used very often in industry because a 480 voltage system is more economical for large motor loads. At the panel board, it a grounding conductor is added and it runs continuously through all branch circuits. The availability of 120 volts or 208 volts in single or three-phase leads to a number of circuit or feeder arrangement that can supply the following loads. First is the 120 volt single phase two-wire branch circuit. Next is the 208 voltage single phase two-wire branch circuit. 200 voltage three-phase three-wire branch circuit and 120 208 voltage three-phase three-wire feeder or branch circuit. Next slide, please. Next is the 480 277 volt alternating current three-phase four-wire system. This is the common electrical service in the most modern commercial buildings. The Y in the system relates to a WYE winding configuration of the secondary windings of the transformer, producing a three-phase current. Large retail shopping malls, schools, grocery, supermarkets, and office buildings. We use this system for its 277 voltage fluorescent lighting capabilities. At the panel boards or switchboard, a grounding conductor is added. The ungrounded hot conductors are known as the X, Y, and Z phases. Voltage measured across the connection of any single ungrounded conductor. And the neutral conductor provides 277 voltage single phase. Three-phase motors and other equipment that operate on three-phase power are connected to the three ungrounded conductors, X, Y, and Z phases. The availability of 277 volts or 480 voltage in single or three phases offers the following circuit or feeder configurations, which is the following: 277 voltage single phase two-wire branch circuit, 480 voltage single phase two-wire branch circuit, 480 voltage three-phase three-wire branch circuit, and 277 480 voltage three-phase three-wire feeder or branch circuit. When compared with the 208 120 voltage system, the 480 277 voltage system has economic advantage from the standpoint of equipment and conductors because a given conductor can carry more than twice the load at 480 voltage than at 208 voltage. The savings in wire size for feeders can be quite significant. The 480 277 voltage system. Next, please. So next is the 600 346 volt alternating current three-phase four-wire system. This is the less common electrical service in large commercial and industrial buildings that is used to power specially designed heavy machinery. This system is designed like the 480 277 volts alternating system described earlier, except that 600 volts and 346 volts are available in the circuit or feeder configurations. The 600 346 volt system has additional economic advantages from the standpoint of equipment and conductor sizing in comparison to the 208 120, and 480 to 177 voltage systems. So next, please. So last is the 240, 120 volts alternating current three-phase four-wire system. This is another fairly common electrical service found in commercial and industrial buildings where three-phase motors above 1 to 2 horsepower and equipment such as large air conditioners are used. On this three-phase four-wire system, delta connected system, the midpoint one-phase winding is neutral to provide 120 volts between phase X and ground and phase Z and the ground only. There are 240 volts between the windings of each phase, that is, between phases X and Y, phases X and Z, or phases Y and Z. Between phase Y and ground, there is 208 voltage available. The availability of 120 volts, 208 volts, and 240 volts in single or three-phase offers a number of circuit or feeder options that can supply the following loads. 120 volt single phase two-wire branch circuit, phase X and ground, and phase Z and ground. 208 voltage single phase two-wire branch circuit, phase Y and ground. 240 voltage three-phase three-wire branch circuit. 120 240 volts three-phase three-wire feeder or branch circuit. That's all, and thank you.
Thank you so much, Dems, for that wonderful presentation. So right now we will go to incognito because I don't know if you're familiar with this slide. Shane, take the stage.
Good evening, guys. Our topic would be system voltage, utilization voltage, and maximum voltage. So next, Job. We'll have a quick recap. So voltage is a pressure from an electric circuit power source that pushes charged electrons through a conducting loop, enabling them to do work such as illuminating a light. Next, Job. So system voltage is also known as nominal voltage. It is a value assigned to a circuit or system to designate its voltage class conveniently. The actual voltage at which a circuit operates can vary from the nominal voltage within a range that permits satisfactory operation of equipment. So nominal voltage is also known as the convenience. So it conveniently designates the rating of one piece of equipment to help match up with another piece of equipment. Nominal rating help match batteries, solar panels, charge controllers, and load. So example is 12 volts battery can be matched with 12 volts nominal charge controller and a 12 volts nominal solar panels. So the actual operating voltage of these pieces of equipment could be widely differ from the nominal rating. So remember that nominal rating, again, is just to help match up equipment. For example, the nominal battery voltage is 12 voltage, and then the actual operating voltage can vary from 12.9 or 11.5. That is still in range of a 12 volts nominal voltage, same as with the example number 2. Next, Job. So, Jovi, wala yung share. So utilization voltages. So utilization voltage means that the voltage levels employed by the utilities customer for connection to lighting fixtures, motors, heaters, or other electrically operated equipment other than power transformer. So, I i-explain na nako ni siya unsay gakahitabo. So, next, Joe. So I have this example. So naa ni siya konektado ni siya sa isa ka system bitaw ay isa ka equipment, and then ang iyang gibuhat is gitas niya kung pila ang utilization voltage sa kana nga butang. So for example, ang nominal voltage na iyang gigamit is 120 volts. So ang utilization voltage quickly pag wala pa siya gigamit kay ga-range siya from 119.6 ang iyang utilization voltage. But then, if i-on na nato ang ato ang gamit or ang equipment, kay automatically, tungod sa pressure, kay mag-change iyahang utilization voltage na na munaog siya, pero along the way, kay mo-increase na gyapon siya. So, mahimo siyang 107.2 pag-start mismo sa system nga imo ang ginagamit. So, next group. So, kani siya, nganong niabot siya near sa voltage drop is because when we quickly turn off our ang breakers or kanang we quickly switch off something ay kanang ingana kay pag turn on nato ana, seconds after pag turn on nato ana, ang utilization voltage natin is near siya sa voltage drop. Mao ang uban company or uban balay kay ga-install sila og assist device wherein kung naaman yung assist device, dili na siya munir sa voltage drop and quickly pag turn on nila sa system kay mo immediate start siya. So ang nahitabo ani kay pag turn on sa equipment or sa system kay nahimo siyang 105.2. And then pero musaka na siya after seconds. Pero if ano man yun na siya kay ang perks sa pag-install sa assist device kay para dili bitaw mag-flicker ang lights if i-turn on, turn off na to siya. And then, makita ninyo nga if i-install na to ang assist device, kaya ng 118.4, diretso mag-start ang ato ang utilization voltage if naatay assist device nga ginagamit. So, next, please. Asan ako? So, maximum voltage. So, wiring devices such as switches, receptacles, relays, and conductors and electrical equipment are manufactured to endure voltages slightly higher than the utilization voltage. So the highest voltage to which a wiring device can be exposed is known as the maximum voltage. So it doesn't mean guys na if ma-reach sa ato ang utilization voltage ang maximum voltage, quickly mo turn off na imong system. Kay nangutana ko ana sa mong engineer kay naa daw sila ginatawag nga cut-off voltage. So mauna ng time nga ma-turn off ang system if dira na mo lapas ang ato ang utilization voltage. Pero kaning maximum voltage is gahatag siya space sa ato para if ever mo dagan gihapon siya. So next. So ganit na. So, inyong gikakita karon is just a basic diagram of PV system. So, remember that the highest voltage is always related to a measurement between two different conductors, and that conductors can be a bunch of different different ones. So, for example, positive, negative and ground, positive and etc. Go on. And then, so, ang kakahitaboan na niya is when we wire from positive kanang naa sa taas to negative nga naa sa ubos, if ma-wire together siya in a series circuit, that actually increases our voltage and keeps the current same. But when we combine sa parallel and connect all the negatives and positive together inside kanang combiner box kay kanang gray nga inyong gakakita sa inyong screen, that's when the voltage remains the same but the current actually increases. Like for example, kanang each inyong gakakita ana is gaano sila og 4 modules connected in series kay 40 volts and 9 amperes. So 40 times 4 is equals to 160 voltage. So up and down 160. And then ang amperes anang 4 kay 9 amperes. And then sa bottom dayon is 9 amperes. So pagsulod nila sa combination box, combination box ba? Ay combine box kay ano dayon kay ang voltage nato kay mag-remain siya the same, but ang atong amperes kay mo increase. Mao na siya ang mosulod sa ato ang ginatawag nga inverter. So, na quick facts na natun-an ako while ga discover ko kay nag-quick experiment man jud ko sa among compressor. So the lower the voltage daw kay the higher the current, and the higher the voltage the lower the current. So mas tipid sa electricity kung kay gamay og ampere. So oto next. Maura to guys. Thank you. Dili ko mag-ask you questions.
Okay, thank you so much for our last reporter, Shane Valdeweza. Thank you so much, guys, for listening, and God bless you all. I guess moral to siya, sir.
Maayo nga pagka-present group. Sa kani mga group gani 4 no 5.
5 po.
Nabuak pag yung speech. Dito kay. Maayo nga pagka-present.
Thank you, sir.
Thank you, sir.
Speak ko as a whole sa inyong team ha. Preparado. Well, so dili na ko mangutana since nag-question naman mo. So nakuan lang ko na wow, nag-question sila bay. So na-happy lang ko. Charot. Bitaw, proceed sa report group 4.
Okay, sir. Makita na ang kuan, guys. Hello.
Yes, Curbs.
Yes,
Curbs.
Kita lang dito.
So, good evening, everyone. We are the fourth group tackling these specific topics. So, here are my colleagues and their corresponding topics. So, first, grounded and ungrounded conductors will be reported by Lovely Toquero, which mag-play lang ko og recording kay since na siya sa hospital karon and she needs to rest. So the next one is the system and circuit grounding brought to you by Lloyd Vincent Baconga, and then the building electrical system by Maureen Tixon and Mary Josephine Taub, and the conductor requirements by Ryan Mogot, and then lastly are the conductor voltage drop requirements and insulation color coding in the identification and markings brought to you by Janelle Rose Biniga and yours truly. So to start with, let us watch and listen to this to the recording of Lovely Toquero.
Hi guys, so let's talk about grounded and ungrounded conductors. So, what is grounded and undergrounded conductor? The grounded and ungrounded conductors are necessary to complete an electrical circuit. They provide a continuous path from the load to the ground. Both conductors are connected to the earth, to the ground, but there are differences in the location and the function of each of these conductors. These two differences are addressed in the following sections. Grounded conductor. In a single-phase branch circuit, a grounded conductor serves as the grounded leg of the circuit. It completes the circuit by connecting the ungrounded, which is hot conductor, to the ground. Those in the circuit design, the grounded conductor is considered to be a current carrying conductor because it serves as a return path back to the circuit power source. So, on a two-tire branch circuit, 120 volume circuit with one undergrounded conductor and one grounded conductor. The grounded conductor carries current equal to the load. So, for example, Ana, is if the um, if the ground, which is hot conductor, is feeding a load of 12, and then the grounded conductor carries 12. So what I'm saying is, as a result, the grounded conductor must be sized at the same ampacity as a ungrounded hot conductor. So meaning ana, kung pila, I mean kung pila to ka loads ang dala sa uh, ungrounded conductor, mo dapat sadto ang dala sa grounded conductor. Dapat same sila og same ilang loads nga gidala ato. Muna siya dapat the grounded conductor must be sized at the same ampacity at the ground conductor. Dapat same loads lang para mabalance. Neutral conductor. A neutral conductor performs the function of a grounded conductor for at least two ungrounded conductor that have sources from different voltage phases, such as on a multi-wire branch circuit, multi-wire feeder, and electrical service. This three is the different voltage phases of a neutral conductor. So, the conductor serves by a neutral must measured voltage between the ungrounded conductors by protected by the double or triple pole breaker or set of fuses. So a neutral conductor cannot by definition serve a single 120 volt circuit because it has only one grounded conductor. A neutral conductor is a grounded conductor that is shared between two or more ungrounded conductor. Those in neutral conductor is frequently called a shared neutral or a common neutral. So in a 120 over 240 volts, 3-wire service entrance feeder or branch circuit. There is a neutral conductor and two grounded conductors. Tagsa-tagsa sa ila is na ay 120 volts to ground, and neutral conductor is also present in 208 over 120 volts and 480 over 277 volts services, feeder, and circuits. Grounded and neutral conductors should always be insulated because they can carry current. They should be continuous because they provide a path to complete the circuit or circuits. The neutral conductor is a grounded at the transformer and at the service equipment, switchboard or panel board. In this case, it is connected to ground much like the grounded conductor. At the sub-panel board serves by a feeder, an equipment grounding conductor, and a neutral conductor remains separated. This way, each circuit extending from the sub-panel board has a separated equipment grounding conductor and a neutral conductor. So, grounded and neutral conductor should be wired so a circuit breaker, fuses, or switch thus not interrupt them. A switch or overcurrent device located to the grounded or neutral conductor allows the remainder as much of the circuit. So here's the example of a neutral conductor. So we know naman Goro guys na nakakita na tatanan sa switch off ng lights da sa itong mga house, tag sa house. So this is the example of neutral conductor. A branch circuit services several lights fixture with a switch connected to the ground conductor. Instead of the ungrounded hot conductor, when the switch is closed, the circuit is complete and the lamps light. When the switch is open, the lamps are off. It appears the circuit is controlled and wired properly. But there are concerns. With the switch open and the circuit wiring and the lights fixture are still hot, that's it. The power runs through the ungrounded wiring to the lamps and through the grounded wiring to open the switch where it interrupts. So the lamp in the fire fixture do not light, but the circuit wiring is hot in the open switch. Similarly, is a circuit breaker or fuse located in the grounded conductor may open the circuit because of a short circuit or current overload, but the circuit wiring all remain hot. And a hot circuit is a potentially hazardous condition because it unnecessarily exposes occupants or to the hot wiring. So that's the example of the neutral conductor. Load balancing. And load balancing is a practice of dividing loads as evenly as possible between the ungrounded conductors in a multi-wire circuit, feeder, or a service. Balancing 240 volume circuit on a 120 over 240 volume 3-wire single phase system is easily accomplished because the loads is the same on each phase conductor serving the circuit. Loads must be evenly divided between the hot conductors. 3-pole circuit breakers connect to the panel board so that the non-breaker connects to the phase A bus. And the other breaker does the same for phase B. And the basic way to attempt to balance load at the panel board is to connect an equal number of branch circuits to each ungrounded bus. The neutral conductor is sized to carry the maximum unbalanced current in a circuit. For instance, the large loads between the neutral and any one ungrounded phase conductor. So as a current carrying conductor,